Good afternoon, everyone. My name is Palmer McIntyre, coordinator for the Great Trail State Coalition. I'm excited to have you all here today at Cities, Towns, and Counties for Trails. We have a webinar series going, and today we're very lucky to have some folks from the Triangle area to present about the White Oak Greenway and the challenges getting that project completed as a critical connection and in a difficult area. And today we have Paul Kuhn from the town of Cary. We've got Jeff Moore from Kimley-Horne, and we've got Jason Philbin from PermaTrak. And they're going to tell us how they solved this amazing challenge and how they all work together to get the project done. So I'm going to turn it over to you all for your introductions.
Great. Thanks, Palmer, for that. I'll go ahead and introduce myself. I'm Paul Kuhn, and then I'll ask Jeff and Jason to introduce them while I'm sharing my screen. But I'm Paul Kuhn. I'm currently the Capital Program Manager for Cary, right here in the Triangle area next to Raleigh, Apex, Durham, kind of all together. I'm a professional landscape architect. Worked in Cary for over 2 decades on a variety of interdisciplinary projects, from the planning, design, construction, going after grants on parks, greenways, and other facilities that we build here in Cary. I'm a member of the North Carolina American Society of Landscape Architects on their executive committee, and I hold a BLA and a planning minor from Kansas State University. And when I'm not working or doing things around the house, I'm usually out on a greenway on my bike, checking out, seeing what other people are doing, and getting great ideas. So with that, I'll go ahead and turn it over to Jeff for an introduction.
Thank you, Paul. As Paul mentioned, Jeff Moore with Kimley-Horne. I'm a senior project manager, specializing in surface transportation projects such as roadway, greenway, sidewalk, multi-use path, really any type of infrastructure of that kind. Been with Kimley-Horne for 25 years and served as the consultant project manager for the White Oak Greenway that we're going to speak of today. And I also had the pleasure of working with Palmer on the Great Trail State Executive Committee. Jason?
Yeah, thank you, Jeff. My name is Jason Philbin. I'm a professional engineer also, like Jeff. I'm registered in 40 states, and I'm the owner and the CEO for PermaTrak North America, which is a company based out of Charlotte, North Carolina. PermaTrak, as you'll find out in a few slides, is a precast concrete boardwalk system for boardwalks, bikeways, pedestrian bridges in the greenway market space. And the town of Cary is one of our best customers. Kimley-Horne has been a specifier of our system for years throughout the country. Our system is installed throughout North America. So we have Canadian projects as well as United States of America projects, and we've been installed in 40 states so far. Thus why I'm registered in 40 states. Like Paul, I'm an avid cyclist, triathlete, if you can't tell by some of the flags behind my head. I do some triathlons, and I love being on the bikeways and greenways, and I can tell you what, there are some fantastic greenways across the country. Town of Cary is one of the tops in the country. So with that, I'll turn it over to Paul and let Paul get us started.
All right. Well, thank you all for joining today. And we're going to talk about the resurrecting of the White Oak Creek Greenway with strategic partnerships. And here we go. You just saw and heard about us. So we're going to give a little overview, talk about the collaboration and funding that we used, some of the design challenges. Jeff will kind of dive into that aspect. Jason will dive into the boardwalk solution, and then kind of the outcomes and significance, and have probably a few minutes for Q&A at the end. But also, if you have something along the line, feel free to type it into the chat, and we'll see if we can answer it as we go along. So just to get started, we started this project back in 1998. That's when we got the approved Parks Greenway and Bikeways Master Plan. And that's when we first showed this connection occurring in Cary. So in about 2002, we hired a design team to start working on this project because it was kind of in a developing area of Cary, and we wanted to proceed with it. But quickly, they determined that there was many challenges, including the railroad tracks, there was a stream, it was a narrow corridor where we were trying to get to put the trail. We'll get into those details a little bit more. But after kind of doing some preliminary design, the project was pretty much shelved around 2002. In Cary at the time, we had a lot of other greenways that were in the works, so we started working on them. And at this location, we actually were connecting to other trails that were kind of in the works. And we had a 1.5-mile detour, so we did have a kind of a temporary detour, so that allowed us to kind of focus on some other things. But just to give you a little bit bigger picture, as you know, around this time, the East Coast Greenway was working on designating the alignment on the East Coast. And so when Cary heard about it, we wanted to jump on board and be part of connecting Maine to Florida and being part of that 3,000-mile trail. And I'm pretty sure most of the people on this call are familiar with that, so won't go into too much other detail on that. But for Cary, we're approaching right around 100 miles of paved greenways within our trail network. And in 2019, we celebrated 40 years of greenways within Cary. And we've worked, as Cary has grown, we've worked with development and developers to build many of those trails. And then some of the more challenging ones we've come back and Cary has built, and this is one of those. And Cary currently has a population of 180,000 people roughly. So on those 100 miles of trails that I mentioned, we have over 170 structures that we have to maintain. And these structures range from boardwalks, bridges, and tunnels. And so our public works are always looking at our new projects and asking, how can we reduce the maintenance that we're having to do on these, because they're out there all the time maintaining them. So around 2004, we were really focused on, in this map, you can see Cary kind of in yellow. And if you look closely, you may be able to see the White Oak Creek Greenway labeled here, and then the Black Creek Greenway, and it connected in Bond Park. And so this was really our big push, because we were trying to connect the American Tobacco Trail, which is on the west side of the county, up to Umstead State Park. So Cary had those two great connections that we can make. And by making those connections, we were able to then connect to Durham, Raleigh, and some of the other connections that are shown on this map. Including the Neuse River Greenway, which is the trail on the far east side of the map and the east side of the county. And that's obviously a big trail. Raleigh's done a really good job with that trail connection. So being able to connect Durham to Johnston County was our goal. And you can see this map was from when we were working on the project, that we really had this one little gap that we really needed to kind of complete this whole network that we had. So zooming in on the project, this orange line is basically the 0.4 of a mile project that we were working on. And we really were trying to connect from MacArthur Drive up to Davis Drive, and we had trails on either side of this that we were connecting to. We had a park over by Davis Drive that we would be going through. And then you can see it was threaded through a narrow HOA property. And when the neighborhood developed, they granted Cary an easement on this property. So that was part of Kimley-Horne's challenge, was trying to thread this trail through that sliver of property along a creek. There's a sewer, and then there's a railroad. And that's probably one of the biggest and unique things about this project, was working with the railroad. And for our elected officials, when we came to them and said, hey, we want to work on this project, we want to restart it because it's completing this big gap, they wanted to be part of the East Coast Greenway. They wanted to be part of something bigger than just something in Cary. So it was an easy sell to them. I think everybody's probably familiar with the Appalachian Trail. And so when you explain the East Coast Greenway being kind of that urban version of it, it was a no-brainer for people to understand what we were trying to do. So in 2012, Cary had a parks bond referendum, and it was for $15.87 million. And a portion of that funding, roughly $2.5 million, was identified to complete this missing gap on the Greenway. The bond passed at 77% approval. And so once we had that money, that allowed us to start design and look to leverage that funding in order to go after other grants and start the design process. So in 2015, we went after grant funding through NCDOT and our local MPO, and we ultimately got $3.8 million in grants. And then the total project cost was $9 million for this 0.4 of a mile greenway. So here's a few images that we took relatively after construction was completed. And so you can kind of see the tunnel, some of the boardwalk, some of the connections that were made. And I kind of like looking at this picture now because if you go out there now, the vegetation is, especially some of these trees near the tunnel, are really big. And that's what I love about North Carolina is vegetation grows really fast. So even though, yes, during construction, we had to cut some trees down, we had to disturb some areas. As part of this overall plan, we replanted areas back, restabilized the stream, naturalized it. And now it's almost a little overgrown, and we're only 5 years since opening. And to just kind of talk about our process of our partners that we went through. So Cary went through the request for qualification process, or RFQ, as I'm sure you've heard, and to hire a design team. We had 5 design teams submit proposals to Cary saying, hey, hire us and we'll design you this project and get you across the railroad tracks along the stream corridor and figure that out. We selected Kimley-Horne because of the team they put together, their experience, and they had a sub-consultant called STV who had very specific experience working on the railroad and tunnel. And their assistance in that was very helpful, along with Kimley-Horne, on the overall coordination of the project. And then we have listed here our contractors that helped on the project, and that included Crowder Construction, who was the general contractor on the project. And they hired PermaTrak to provide the boardwalk, and then we had JMT doing the construction management to ensure we were meeting all the federal paperwork requirements, overseeing construction and that side of things. So there are a few more team members, but these were the primary ones working on the project and getting it. So with that, I want to turn it over to Jeff to kind of start talking about the design.
Thank you, Paul. So as the slide suggests, we're going to talk about our design challenges and break it up into 3 different sections, starting on the west side with Davis Drive with the park. Then the biggest challenge was the railroad crossing itself. And then we'll finish up with the homeowners association property, the easement that we threaded the needle through. Next slide. So in order to set the stage, it's important to show kind of an overall project slide, similar to what Paul showed earlier. On the west side, you see we began the project right on Davis Drive itself, meandered around the park, went underneath the railroad, and then as we came out from the railroad, we basically began a, I think, 915-foot long boardwalk. I think Jason will correct me if that's not right. And then once we got to the end of the boardwalk, we were able to connect with MacArthur Drive on the other side. Next slide. So navigating through Davis Drive had some challenges. And the first one was, I'm sorry, Paul, if you go back to the previous slide, you'll notice on Davis Drive, there's a large soccer field. That is a FIFA soccer field, which is the Federation Internationale de Football Association. They are very persnickety about the size and arrangement of their courts. So we had to make sure that we met their guidelines and their requirements. We were also able to use the parking lot area for temporary construction and staging. Very helpful for the contractor to be able to lay down and have materials dropped off. And then next slide. We also have had to build a 10-foot tall black vinyl coated chain link fence with 20-foot netting at the top to hold back all the soccer balls within the soccer field itself. So those are just small little details that we worked out as far as the design is concerned. Next slide. So the railroad crossing, as I mentioned, was one of the biggest challenges. And with those, we evaluated whether to go over or under the railroad. That was kind of the first evaluation that we did when we first got started. I'm going to talk about how we came to that decision, some of the factors that went into it. Then I'm going to focus on the design of the tunnel and then the construction of the tunnel and focus on those items. Next slide. So from the underpass component, we investigated looking over as an overpass as well as an underpass to cross Davis Drive, actually, as well as cross CSX Railroad. We looked at combinations of both to try to figure out how best to navigate this area to make the connection that we were seeking. Both overpasses of the railroad required a pretty significant structure, and elevation wide was going to be like at the height of the second floor bedrooms along the trail on the residential side. So not the best option there. We did the planning for the Davis Drive crossing that I mentioned, and the town hopes to be able to move forward with that sometime in the future. But the town ultimately decided not to construct a grade separation at Davis Drive, but instead focus on the railroad underpass at CSX based on our evaluation. So our proposed methodology was to construct what was called a tunnel liner plate pipe, place that under the CSX railroad. And the biggest advantage of that is we could do that without interrupting the CSX operations. They have trains coming through this area each day, and it was imperative that we not interrupt that operation, and the tunnel liner plate construction was able to do that. And you'll notice the experience of our team, our subconsultants, STV, had actually developed a tunnel liner plate solution under a Norfolk Southern Railroad in Sewanee, Georgia, and brought that experience into this. Next slide. So this is a picture of the tunnel liner plates. This is what they look like when they're brought in, shipped in to the site. They're typically made out of aluminum, and this is them stacked together. And then that's on the left side. On the right side is an image of the tunneling operation. So what they basically do, they have a machine that digs about 18 inches into the tunnel, into the dirt. And then once they've excavated that, they basically put those tunnel liner plates together all around in a circular fashion, basically 18 inches at a time. So that they basically do this 24/7 until the operation is complete. That's the CSX requirement. But they'll basically excavate enough to go 18 inches, bolt that together, and go another 18 inches and bolt that together. And I think Paul, they were able to do this in like less than a month, just because they were able to go do it nonstop. And rock's always a big problem that we run into, but I think just under this area we were able to keep trucking pretty quickly.
17 days is what it took.
Oh, 17 days. Thank you. I forgot that from our September conference. So 17 days and this is a 100-foot long tunnel in 17 days. So engineering marvel.
Yeah.
And then the bottom right corner is basically what it looks like when it tunnels all the way through and goes to the other side. All right, next slide.
And Jeff, I believe these were the images you used at your interview. Was that?
That's right.
Yeah.
So this is a picture of the Sewanee, Georgia application. We shared those with the town during our interview process to show them our experience of doing this. And I thought they looked great for the presentation, for the Great Trail State. All right, so as far as the tunnel design itself, we had to span the entire railroad right of way. It was 100 feet long, so our tunnel was actually 102 feet, just to add another foot on either end, so that this allows CSX to be able to expand their rail their rail tracks if they need to in the future without having to touch our structure. It allows them, latitude to move the existing over and add a second track. And I'm also going to talk about the ballast to plate minimum depth. Talk a little bit more about the aluminum plate type and size. I've got a slide for that. Talk about that continuous operation, and then wrap up the tunnel design with drainage. So next slide. So this is basically a very scaled back CAD drawing of it's just the culvert itself in plan view, that how it spans the entire railroad right of way, and how we kind of curved in, went straight across. You got to go straight across the perpendicular just to minimize the crossing, and it needs to be a straight shot so that it's easier to construct this type of facility, obviously. Next slide. So this is the ballast to plate minimum depth. We had to be 5.5 feet from the top of the tunnel liner plate to the bottom of the track. That was an absolute. And the bad news is that puts us pretty deep down in that area. The outer diameter of the tunnel liner plate, I know this is a little bit sketchy to be able to see those numbers, but it ends up being 169.25 inch. That's a nominal railroad diameter. It's about 14 feet. But that's how big this pipe is when it's put in the ground, 14 feet. And what you see there inside the pipe is about a 10-foot width and an 8-foot height, almost rectangular 10 by 8. So you say 8 feet's kind of thin. Well, that would be what it is over on the sides. But at the top of the arch, it's a little bit over 10 feet. So, very comfortable for bikers, to go through there. We didn't want to go any smaller just because of the nature of trying to create the most efficient operation for safety and for ease of users. Next slide.
And there's the drainage pipe in there too.
That's right. So the drainage pipe is what we'll talk about here in this next slide. So by putting in a 14-foot diameter pipe under the railroad tracks, that's a lot lower than everything else. We had to drain it. So we basically set up a system to drain the sag, basically a 1% grade coming out of it, which took some number of hundreds of feet to drain it to this outlet and connect it to the existing stream. Next slide. So this is just a quick slide to show something we realized during design is, in order for the contractor to actually build this, we can't just start on one side and work your way to the other. The contractor has to have access on both sides. So we worked out a temporary crossing, put in the provisions for a temporary crossing and the permissions from the railroad company to be able to do that. And that opened up the door for them to be able to work on both sides. And from an access perspective was huge. Next slide. So these are some tunnel construction slides. I'll start on the left side. Shows you the sheet piles that were constructed to allow excavation for the tunneling operation. It's the tunneling machine before it begins their operation. And then you can, in the bottom right is one of my favorites, just because it shows you the tunnel operation, but it shows you the railroad on top. So the railroads were able to go over, like I mentioned, over our operation without hindrance, and that was huge. Well, it was a requirement. It was obviously not just important, but it was a requirement. So something we had to do, and this operation allowed us to do that. Next slide. So image on the left just shows the workers inside the tunnel, probably putting in grout or checking the bolts and the nuts and bolts of how it comes together. The images on the right basically show continued operations of bringing grout and concrete in and out of the tunnel. And then on the bottom right shows our actual project as it broke through to the other side. Next slides. That shows the grout operation, at the very end, after they had placed the walking path and the railings on each side, that basically put in a grout, Shot Creek grout type situation to protect the tunnel from water. And then the upper right shows that as well, and a little bit of water in the walkway, of course, just as it's coming through. And then the bottom right shows the final product. This is what it looked like as soon as, well, it's probably the day we opened the trail. You have bikes using it already. So great to see. It was great to see that happen almost immediately. So now, next slide. So now I'll finish up with the homeowners association property, how we threaded the needle. We had a very limited area to operate. There was an existing sewer line, existing stream, wetlands all over the place. So we had really a boardwalk was the only logical solution. And Jason will finish that up here in a few minutes. And we had to address the neighbor concerns because if you'll go to the next slide, I'll explain. So when the developer developed this neighborhood, this residential community, they dedicated 50 feet to the town for a greenway, which is great. Only problem is there's a stream and a wetland series of pockets about it right in the middle of the 50 feet. So thanks, but it did create some challenges associated with where do you put a trail then if the stream, which is a jurisdictional stream, probably shouldn't be touched, probably shouldn't, you don't want to, agencies don't like those being relocated necessarily. They frown upon that. And then on top of that, you'll notice the purple lines, the thicker purple lines are the easement. And then on the upper part of this drawing is a 20-foot sewer easement. So there's actually a sanitary sewer as well. So it would be great to use that area because there's no stream, but that's where the sewer is. So you can't use that either. So it's, it makes a very small pocket of room to build. And then as you can tell, the stream just kind of meanders. It's not straight. And on the southern side, it's kind of in the middle, kind of meanders through. So if you go through, the next slide shows you our solution. So we basically developed a boardwalk alignment to minimize impacts to the wetlands and thread the needle through there to get the project permitted. And the other thing that came up, and you'll see this on the next slide, but another thing that came up was the neighbors. The developer provided a 50-foot easement. We kept our trail in our boardwalk within the easement, but it backs up to the properties. So they expressed concern about privacy. So by putting in a boardwalk, it allowed us to elevate the trail, roughly 2 to 3 feet for environmental protection reasons, but also allowed us to have a railing across both sides, just from a privacy perspective and a safety perspective. So on the left side of the screen, you see the stream and the boardwalk in relation to how close it was to the residences. And then on the right side, you see our tree protection fence, how it we basically ran along the top of the easement all the way through there and established the boundary for the contract. With that, Jason, I'll turn it over to you.
All right, thank you, Jeff. Jeff did a great job of setting up the challenges that we as a boardwalk supplier and designer were challenged and faced with. I will basically cut to what the solution was on this. One of the requirements for the town of Cary is that the surface be slip resistant and also that the material of the boardwalk be a durable, long-lasting product. So our PermaTrak system is a completely precast concrete boardwalk system. So the beams and the treads and the caps that attach to the piles, that's all precast concrete, and that comes as a modular system on a truck and shipped out. And and the railing system can be added to change the look of the boardwalk if you want. And what I'll do here on the next half a dozen slides is I'll show you how those pieces come together, how we traversed the stream and the easement, and how we got through that. And the process started with PermaTrak's team. We have a team of engineers here in Charlotte, and we communicated with Jeff's team, Kimley-Horne, and it became an iterative process. So we began with understanding what the limitations were and where the footprint needed to go or wanted to go. And we prepared a drawing similar to this, where we would show the width of the boardwalk, and they wanted 10-foot clearance, and we wanted to allow for a railing to be attached. And we proposed where we thought the pile system should go to. The geotechnical engineer recommended a timber pile system for this project. So it was a driven timber pile. And so we basically dropped on a piece of paper where the piles would go, where the turns would be, and we And we quickly found out that we had to basically crisscross the stream several times, and that introduced some turns and introduced some larger spans. Most of the spans of the PermaTrak system generally fall between 10-foot spans between piles and 20 feet. But as we got to some of the turns, we had to think a little bit outside the box and go non-standard with some larger spans. And I'll show you that here in a few slides. So next slide, Paul. So these are the components. There's not many. On the left-hand side are the beams, the stringers, the structural members that span from pile to pile. Those span in the longitudinal direction. And on a typical bent from 2 piles to the next piles, we use 2 beams. So you can imagine a left beam and a right beam, and it's just repeated for the entire 915 feet of boardwalk. And then once the beams are in place, the middle image, the treads, are placed perpendicular to the beams. So you can imagine, think of it like a big Lego set. You lay the beams and then you lay the treads. And then on the right-hand side, excuse me, is a close-up picture of the treads that were produced for this project. Notice the top surface is textured. Paul's team chose a timber-looking texture. They wanted to mimic the look of a timber, and that gives you a little bit of slip resistance also, and there's other options available. Now, the town also chose the color, a tan color. It's a color we call Melbourne tan, and we offer a couple of different colors also. So this is a Melbourne tan color with a timber texture, and what you're looking at on the treads is a tread that is 2 feet wide by 11'3" long. So imagine walking down the boardwalk, you would have a joint every 2 feet as you're walking down. So think of that as the board. If you're thinking about a timber boardwalk, you would have joints every 2 feet with our system, with the PermaTrak system. So next slide, Paul, please. So this is what it looked like before the PermaTrak arrived. So the contractor hired Span Builders, which is a local smaller construction company in Raleigh area. They installed the timber piles. They basically started on one end and they backed their way out. They were able to drive the piles from the ground, and they drove those timber piles in the ground. And then based on our drawings and the feedback from Jeff's team, we established what the cutoff elevation was on the top of the pile. And remember, once you cut the pile, then the first PermaTrak piece, which is a circular cap. And let's go to the next page, Paul. And you'll see here, look at those circular, they look almost like a wheel, like a wagon wheel. That's a cap. It just gets positioned on the top of the timber pile. And it's purely there so that it gives a bigger bullseye or landing target for the beams when they come into the pile. It would be a challenge if we eliminated the caps, because the top of the timber pile may only be 12 inches, 10 inches in diameter. So that's a pretty narrow target to hit for a contractor. So those caps are 18 inches in diameter. And Paul, let's go to the next page, please. And this is a close-up of what it looks like. Look at the cap, the circular piece on the bottom. There's a hole, a recessed hole in the middle, and there's a through bolt that gets sent through the hole and is lag screw, and it's twisted and fastened to the top of the timber pile. That secures the cap to the pile. You'll also notice there's what looks like a little piece of plastic on top of the cap. That's just an identification mark for the NCDOT. NCDOT inspected this product, so it's NCDOT approved product. And you'll see those pieces on a lot of the pieces that are there. Now, on top of the cap is the beam, and that beam that you're pointing to there is is a 14-inch tall beam. It will span 24 feet off the top of the page. So 24-foot long beam, and it's 14 inches tall, 10 inches wide. That's a precast concrete beam. Now look on the top of the beam. That also has a hole that allows for a lag screw to go through the hole and is drilled and epoxied into the top of the cap. That's what secures the beam to the cap. And then once the beam is set, we lay down a rubber leveling pad, which you cannot see in this picture, but it will run the entire length of the beam. And that helps to prevent some rocking of the treads as they sit on top of the beam. Now the tread, remember, is that the piece that sits on top of the beam. It runs from the right side of the picture to the left. And you'll notice, you can see the joints between the beams every 2 feet is where the PermaTrak treads sit. Notice also just on the left side of the picture, you'll see what looks like a nub. It's a tongue and groove right there where Paul's pointing. That's an interlocking mechanism from one tread to the next. So that helps the contractor line up one piece to the next piece as they're positioning those treads into place. Okay, let's go to the next page, Paul. And then, so that's how the system goes together. So it's very repetitive. After you set one span, you're repeating the process. You set 2 caps, you set 2 beams, you set a number of treads until you get to the next span, and you continue on. Now, some of the details that are unique to this project, the very beginning point. As you're coming out of the tunnel that Jeff described, there's a concrete sidewalk or concrete pathway that ran up to the beginning of the boardwalk. And the question that I get a lot is, how do you handle those tie-in details? So it works out quite nicely. Right there where the arrow is the very beginning of the PermaTrak. And the approaching concrete pathway basically just runs in and turns down. So a turn down slab detail is used, and it rests on top of a poured in place grade beam. The grade beam will run from the left side of the greenway to the right side. It encases 2 piles that are at the very beginning point of the boardwalk. And that's something that we designed. The contractor poured it in place. And then once the boardwalk is set, that turn down slab is then poured. And it's a really nice detail because nothing's perfect in the field. And once the precast is set, and if it's off a little bit, if it's a little short or a little long, or our precast is off in our manufacturing process, the turn down slab will hide all of those imperfections. So it may not match up exactly, but the turn down slab makes it look like it was all intended to be exactly that way. So that's a good detail that's worked out well for us. Okay, next detail, or next slide, Paul. And one of the other challenges I mentioned was, as the boardwalk had to turn left and right and avoid the stream, we had to adjust the span length. So we would like to produce the beams all the same length. In our world, in the precast world, repetition is where you make your margins. But when we start changing things, we have to think differently, and it slows the process down. But we have the ability to produce longer beams. My background is in precast bridges. I've designed highway bridges, so we're very comfortable designing much bigger beams than 24-foot span. And in fact, on this project, because we had to span a stream, we needed to design a 30-foot span crossing, which is what you see in the picture here. So from one side of the span of the stream to the other, we designed a poured in place grade beam like you see there. And then on top of the grade beam sat that 30-foot span that spanned from one grade beam to the next. Now, while we're looking at this picture also, you can look at the treads, the tread on the right-hand side, and then the one next to it, right where Paul's mouse is. You'll see that those treads look quite a bit larger than 2 feet. The normal tread is 2 feet, but that tread that sits in the corner was custom made for the turn that was required at that particular junction. So the first 2 treads you see from the right-hand side of the picture on, those were custom made treads, and they were made just to fit exactly like a jigsaw puzzle for the alignment. And we had to do that on a number of turns as you go from the beginning to the end. Okay, next slide, Paul. And here's a good side view of how that long span is. Now, another question I get is, what do you do about the railings, Jason? I understand the precast, it seems to fit. I understand how all the pieces go together. What do you do about the railing? Well, the railing that attaches to our boardwalk is typically decided by the landscape architect and the owner. So that could be anything. And you saw that this particular setting was in a residential area. There were homes on both sides. And I believe the opinion was, hey, we'd like to soften the look of the concrete up. This is in a residential setting. Why don't we use a timber railing system? And so a timber railing system was used. You see that there's a vertical post that sit on top of the tread. And on the right-hand side, I've shown you a close-up of what the bracket looks like. And the bracket is a galvanized steel post that we supplied and we designed. And the bottom of the post has 2 holes that match up with preformed holes in the tread. If we were to climb under the boardwalk and look up from the bottom of the tread, you would see 2 bolts that would go through the tread and a matching base plate, the same size as the base plate of that particular bracket. So it sort of sandwiches the bracket to the tread. And once the bracket is in place, then that 4x4 or a 6x6 post is just positioned vertically in that bracket. And then there's two horizontal bolts that go through the post to secure the post to the bracket. Railing installers like that because it allows them to work from the top of the boardwalk. They can bring the product in from the top of the boardwalk. They're not having to hang off the side of the boardwalk and use scaffolding to build a railing system. They simply build from the top. So that's how that particular railing system was installed. So next slide, Paul. And you know what I'll say about the boardwalk system, it was 915 feet. We produced that product in probably 6 weeks. And an installation like that, the setting of the precast could be in, now just the precast itself could be installed in about a month. Typically, you think about installing about 50 feet of boardwalk in a day. Some contractors are better than others. Crowder did a very good job, and Span Builders was the installer. They did a good job at installing that. And once the piles were in place and the caps were in place, the boardwalk system went together quite smoothly.
All right. Well, thank you, Jason and Jeff, for kind of diving into the details a little bit more. So to wrap up here, we started construction on this project in 2019, which means we finished during COVID-19. So we were at least able to open up the trail to the public. And we know during COVID, the use of trails was very instrumental, getting people out, that type of thing. So we were super excited that we could at least open it up. We weren't able to do like a typical dedication event at that time because obviously trying to keep space and everything. But what was exciting that did happen was, if you're familiar with the North Carolina Weekend, the TV show on PBS NC, they actually came out and did a 4-minute segment on it and posted it on one of their shows. So we were super excited that our project got that recognition, statewide recognition, that everybody got to see along there. And in that video, they actually interviewed a Wake County commissioner at the time, who was Sig Hutchison. And he noted that this was the Golden Spike project. So if you remember back to one of the earlier maps where I showed the gap of the Neuse River on one side, the American Tobacco on the other side, and we had this gap. And this became our Golden Spike for the triangle of connecting the trails. So yeah, we were really excited about this project, that it's now open. We connect Durham, the American Tobacco Trail, and Cary up to Umstead State Park. And then we connect over to Raleigh's 100+ mile Greenway system and their Neuse River Trail down to Clayton. And it's a great economic tourism opportunity in the triangle, kind of bringing people in and those type of things. And then as this picture shows, Cary has a fairly diverse community, and we like to hold community walks and events on occasion. I believe this was a first walk that we held. And so had people come out and get to enjoy the trail. And then you may have seen on some of the images, you saw a blank concrete wall leading up to the tunnel. And on some of these images, after the trail opened, we actually went back and painted a mural on both sides of it. And it really has a big visual impact. Relatively wasn't that expensive in the project. Cary has a public artist or a public art coordinator on staff. So she helped us get a mural, someone who paints murals, to come up with the ideas and kind of paint on the walls and add some color, some life, some interest, has wildlife, and some different things on there. And even the cyclist in this image here is our former transportation director, who was very instrumental in helping move this project along. So yeah, very fun project. Here's our contact information if you ever have questions or any information, but I believe we have a few minutes maybe for questions, and I haven't been able to track and see if there were any comments or chat or anything in, but yeah, I think Jason, Jeff, and I are all willing to take any questions if there are any.
That's a fantastic project and presentation. Thank you for sharing. It's fascinating, all the challenges you had to overcome. I'm curious how, if you track like the number of users per year that you're getting on that Greenway, do you know?
We do, and I don't have the exact number along there. We used to say like Cary had like 1 million users in our whole system. During COVID, we actually had some of those eco counters, if you're familiar with. And during COVID, the locations where we had the eco counters, we basically tripled the amount of use during COVID. After COVID, it did come down just a little bit, but I think it's stayed up. So I don't know for this exact segment off the top of my head, but I know Cary has probably 2 to 3 million users on our Greenway system.
That's fantastic. Well, are there any questions from the group here? I've got a question, another one. And maybe you said a little bit this, I don't remember, but dealing with CXX, how was that, like with the railroad company?
That's a good question, and I'll let Jeff jump in here a little bit more. But from Cary's perspective, we were just writing them checks. So they could review our plans before they would even look at our stuff and talk to us. We basically had to write them a check to do those type of things. And then Jeff, please jump in here.
Yeah, so Palmer, anytime you work with any of the railroad companies, whether it be CSX or Norfolk Southern, any of the larger, it's all about relationships. And STV supported us in the railroad coordination. Donald Arant was their project manager, who is now at North Carolina Railroad. But Donald was instrumental in coordinating with CSX, and I thought he did a great job. And that doesn't mean it was quick. It just means that they were amenable to this as long as we met their very, very strict criteria. And we did. I mean, because like I said, I think during our presentation, 5.5 feet, you have to meet it. 24-hour operation, you have to do it. So those are the things that we were able to accommodate. And even though it still took a long time, but I felt like it was a pretty amenable process under the circumstances of other railroad projects, or in comparison to other railroad projects.
And Dave's asking, how many years did that take to get the permission?
That is a great question. I think somebody asked me that back in September, and I didn't know the answer. I would guess that it still probably took 1.5 years to go through our design process. Anytime you submit something to the railroads, they have either, I don't know if it's statutory, but a 90-day review time. So as you go back and forth, it can take a while. And sometimes we have to pause to make decisions and come up with, solutions to their questions or their comments. And that takes a little bit of time on our part before we can respond.
Well, 1.5 years sounds really fast, actually.
Yeah. I'll add too, when we were building this project, Cary was building this Greenway project that was crossing the CSX line, and then roughly 5 or 7 miles up the tracks, Cary was also building a new road crossing the railroad track at the same time. Just kind of happened that both projects were occurring simultaneously. But one benefit we got out of having both projects going at the same time is during construction, Cary had to pay for a CSX flagman to be on site whenever we were doing work within the railroad right-of-way. And because we had a project going on at both locations, we were actually able to share that flagman. So the CSX was willing to work with us and said, hey, it makes sense just to have one flagman out here for both projects. So they will work with you along those lines on a few things. Also, all the dirt that was dug out of the railroad right away, the railroad owns that. So any of that material had to go to their specific landfill, their specific area. And so there was very specific things that had to occur because they don't know exactly what might be in that soil, and they want to own it and understand that where it's going and have control of it.
Well, I don't want to hog the question time, but I have two more questions. One is about permitting for the boardwalk area and how challenging that was. And then the other is, how have the residents, the neighbors, felt since the installation about it?
Paul, I'm happy to respond to the permitting side. Anytime that we're able to use a structure and then provide I think it's a 3-foot minimum height from the natural ground to the bottom of the stringers, that's typically, favorable to the agencies. So it makes we still have to go through and get a nationwide permit just because of other impacts in other parts of the project. But by going to the boardwalk solution, it did expedite the permitting as well, in comparison to what it would have been had we continued with more of a paved greenway itself.
And then for the neighbors, we have public meetings during the design process to kind of say, hey, we're restarting this project. Here's the latest concepts, ideas, ask for feedback. I remember we had some people there like, I moved in here 20 years ago. Been waiting for this project to come, so I'm super excited about it. So we had that. There were a few people that lived right back up to it. Obviously, they had some concerns, some questions, some safety things that they were wondering about. But in general, this neighborhood has been fantastic to work with. Actually, Jason and I were out on this trail about a month ago or a little bit less, walking it. And one of the neighbors came up and waved to us and said, hi, how's it going? That type of thing. So it was, it's great being out here, even though we had to work through the clearing and disturbance of everything. And probably the most disruptive thing wasn't necessarily the railroad construction or the boardwalk installation from the decking. It was driving those piles, because they have this big hammer that comes down and hammers that in there. So we tried to do some notifications to the neighborhood. Hey, for this time period, it may be a little bit noisier, etc., and tried to kind of work with the neighbors along that line.
And they have to go to the end to get on it, right? Like unless they climb the.
Yeah, we did get a few questions. Hey, can you cut a gateway or something, a gate into the railing? And it ended up that probably the best way was to go down to the end, go down to the street at either end for them to connect. So yes, the people that do back right up to it can't directly get onto the trail.
Makes sense. Well, how about any other questions for our presenters today? Well, fantastic project. Congratulations, y'all. And thank you for sharing this story. It's an inspiration. Love the fascinating aspects to it, from the tunneling to the boardwalk. It's fantastic. I can't wait to check it out. Well, thank you very much. I'm going to end the recording and